All right, so we are going to start off with number 8. For each of these parts, the first thing I'm going to do is actually write in the definitions. So for letter A, the definition of a critical point, give me a little space. Critical values happen when f prime is equal to 0 or if f prime equals undefined. We know that f increases anytime the derivative is positive. We know f decreases when the derivative is negative. We know we have relative maximums when the sign chart goes from plus 0 or undefined and then minus, and then same thing here. And I'll put the u in this time. The sign chart there would go from negative to plus. All right, absolute max on 0 to 3 we're going to do all on its own. So part A, finding the critical values, I would find the derivative set equal to, let's see, 6x squared minus 18x plus 12. I can factor that, so I'm going to factor out a 6. I'm going to factor it one more time. And then set equal to 0, I get x equal to 2 and x equal to 1. So my critical values are there in part A. So part B, in asking for the increasing and decreasing, I would end up needing a sign chart. The domain of the function was all real numbers, so it's polynomial. I know my sign chart looks like this. You guys should take a little bit more time to pick values and check your signs. And then I would answer the question, increasing from negative infinity to 1, and then union with 2 to infinity. The reason is already above because f prime is positive. Decreasing happens from 1 to 2 because f prime is negative. Letter C asks me for my relative mins and maxes. So looking at the graph here, the graph goes up, flattens, down, flattens, up. So you can tell that at x equal to 1, I have a relative max, and I know that because the derivative at 1 is 0 and f prime changes, plus to minus. And then my minimum occurs when x equals 2 because f prime of 2 is 0 and f prime changes negative to plus. All right, so part D. Part D is a little bit different just because now they're asking you to do this on a closed interval from 0 to 3. Well, now we know that the function is continuous because it's polynomial and it's closed, therefore EVT holds, which tells me that yes, I will have an absolute max and an absolute min. So I'm going to go from 0 to 3 using my sign chart. I'm going to use the same values 1 and 2. They both work from 0 to 3, and then copy in my sign chart. And now, so the only way I would know where my absolute max and mins occur, first of all, if you have trouble with this, I would draw in the function. So you increase, flatten, decrease, flatten, increase. So you can tell we already knew this was a max and this was a min, but look at the end. Now you go up to a point, so this has to be some type of maximum. And this here at the beginning was a minimum. How do I know which one's the absolute? I'm going to do a table of values. So my table of values, I'm going to need my calculator. I'm going to go into y equals. In this case, I'm just going to use the calculator. Oh, no, I'm not, because it told me not to, so I will not use the calculator. So here we go. I filled in the table for you. I did that off to the side, didn't want to have you watch me do that. And just in case you are confused, you're substituting this back into the original, not into the derivative. You're looking for the actual y value. So we know that we have a minimum here and we have a minimum here. We have a maximum here and a maximum at x equal to 3. How do we know which one's the absolute minimum? It's the lowest value. So this would be my absolute. And my absolute maximum would be my highest power value. So there's my absolute. You want to give your explanation if it asks, and my explanation would be that the two possible minimums were at x equal to 0 and x equal to 2, and then you want to say that x equal to 0, the value is less than at x equal to 2. Letter E. So now we are looking at an inflection point. So remember, for an inflection point, not only does the second derivative have to be 0 or undefined, and it has to have a sign change. Some of you forget about that sign change, and that's a major part. Concave up would be where the second derivative is positive. Concave down is where the second derivative is negative. So, given that the first derivative was 6x squared minus 18x plus 12, my second derivative would be 12x minus 18 set equal to 0. X is equal to 3 over 2. There's my second derivative sign chart, domain of all real numbers. And so if x is equal to 3/2, that's where my second derivative is 0. My sign chart looks like this, minus the plus. Therefore, I have a point of inflection, letter E, at x equal to 3/2, because I showed that the second derivative of 3/2 is equal to 0, and f double prime changes sign. Letter F, concave up from 3/2 to infinity because f double prime is positive, and then concave down from negative infinity to 3/2 because f double prime is negative. All right. Number 9. So this was an interesting problem. I think part C is missing, and in your packet, even part B might be missing. So we have that the selected values of a function where the second derivative is greater than 0 from 0 to 4 are given in the table. Use the values to estimate h prime of 3. So when you estimate h prime of 3, the way you do that is you use 1 point before and 1 point after. So really I do h of 4 minus h of 2 all over 4 minus 2. So I'm using the slope, average. To estimate, you're really doing average rate of change. So average rate of change looks like f of b minus f of a all over b minus a, not actual derivative. And so h of 4 is 2.8 minus 1.4 all over 2. So you end up with 1.6 over 2, which is 0.8. In letter B, what is the minimum possible value for h of 5? So this is kind of tricky. Let me erase this so I can use that table and bring it down. There we go. All right, so for letter B, what I want you to notice is that here we added 0.2, here we added 0.4, here we added 0.6, here we added 0.8. So here, the second derivative is always positive. So this was 0.2, this is 0.2, this is 0.2. So in a sense, we're kind of looking at the h prime and h double prime. Here, the only way that your second derivative is going to be positive is if your first derivative, given that it's 0.8, the next value has to increase by at least 0.8. Because if it increases by at least 0.8, then I guarantee that the second derivative is going to be positive. So for h double prime to be positive, it means that h prime has to increase. And for it to increase, we look at what this value would be. So if I do 2.8 plus 0.8, we actually get 3.6. If it was exactly 3.6, then you're not actually increasing the h prime, which means that h double prime could potentially be 0. So what you want for your x equal to 5 is that f of, or h of, 5 has to be bigger than 3.6. So if this was a multiple choice and one of the answers was 3.6, you actually can't pick it because then that makes it so that your h double prime is only 0. So what I'm showing are how much they change by, and if you really think about slope, that's what slope is, how much they change by. What gets really confusing is that the h double prime values are changing by, they're all 0.2. It just has to be a positive value, which is why I did not take this and say, oh, I have to add 0.2. No, I just need there to be an added value so that my h double prime is a positive number. Okay? I'll talk a little bit more about that in class probably. Number 10, ln of 3x squared plus 1, write the linearization at x equal to 1. So the linearization would be that I need the point. All right, and I need the derivative at 1. So the derivative would be 1 over u times the derivative of u. So 6x over 3x squared plus 1. So we get 6 over 4, which is 3 halves. So the linearization at 1 comma ln of 4 would be the slope times x minus x1, and then the y1, I'm moving over to here, so I'm going to add the y value here. Really, what I did was I took y minus y1 equals m times x minus x1, but I moved the y1 to the back of that right side of the equation. So there is my linearization. My part B, my approximation, would be f of 1.2 would be approximately 3 halves times 1.2 minus 1 plus ln of 4. So that would be 3 halves times 1.2, so that'd be 0.2. 0.2 would be 1/5, 2/10, and then plus ln of 4. So we get 3/10 plus ln of 4. All right, and then letter C is your approximation too large or too small. So I'm going to look at, for approximations being too large or too small, you want to look at the second derivative. So, and actually let's do that on a different page because I'll probably run out of space. Ooh. All right, so let's go back and also take my first derivative, which was this guy. All right, so f prime is equal to, so f double prime would be low. D of high minus high, D of low, all over low squared. Now I'm going to look for this at 1.2. So I'm finding f double prime at 1.2 because I want to see if, oh no, was it 1? Yeah, at x equal to 1.2 if we're concave up or concave down. So let's see if we can clean this up a little bit. We get 18x squared plus 6 minus 36x squared all over 3x squared plus 1 squared. We get negative 18x squared plus 6 all over 3x squared plus 1. So because the denominator is squared, the whole thing is squared, that's going to be a positive value in the denominator. Now I just have to check negative 18 times 1.2 squared plus 6. I want to know if that would be a positive value or a negative value. So right now I'm checking if I'm still recording because I don't see the thing. I am. Okay. Got worried there. So 1.2 squared would be a number bigger than 1 multiplied by negative 18, but adding 6, so I know that the numerator would actually be negative. Therefore, this function is concave down at 1.2. So concave down looks like this. The tangent line, anywhere you draw on a concave down function, no matter where it might be, the tangent is always above the function. So what does that mean? It means that the approximation is always bigger than the real. So let's go back and look at the question. It says, is your approximation too large or too small? My approximation is too large because f double prime at 1.2 is positive. I'm sorry, negative. And because it's negative, the tangent line is always above the curve when f double prime is negative. All right, number 11. Find an expression for dy dx. So this is implicit differentiation. We're doing this with respect to y. Sorry, with respect to x. So this becomes a product rule. X dy dx plus y times 1. So that part right here that I just did was the derivative of the product rule. And then dx equals 0. So to find the first derivative, you get all the terms with the dy dx on one side. You move over the other terms. You factor out. And then you are going to divide to get your first derivative. Okay, so hopefully I did that correctly. Find any points on the curve that are horizontal. Tangents. So horizontal tangents happen when the derivative is equal to 0. So I'm going to take my derivative and set it equal to 0. And the only way that that could happen is if the numerator is 0. So I end up with negative 2x minus y equals 0. And I get that y is equal to negative 2x. So that gives me an equation. And since I can't solve that yet, I'm going to put that back into the original. So the reason you can do that is because the point of tangency is an intersection point between the derivative and the curve itself. So I get x squared plus x times y, negative 2x, plus y squared, negative 2x squared, equals 27. So we get x squared minus 2x squared plus 4x squared equals 27. So we get 3x squared equals 27. X is equal to plus or minus 3. So if x is equal to positive 3, I'm going to go up top here. If x is equal to positive 3, then y is equal to negative 2x, so negative 6. If x is equal to negative 3, then y is equal to negative 2x, which would make it positive 6. So the last thing I want to do is just double check that both points work, and I'll do that to the right. So x squared plus x times y plus y squared. Does that equal 27? Yes, it does. And then the second one, x squared would give me 9, plus x times y, which gives me negative 18, plus y squared, which gives me 36, equals 27. Yes, it does. So both points would be points on the curve where the tangent line is horizontal. And now we're going to just do vertical. It's a very similar process. So again, I'm going to take my derivative. I'm going to set the derivative now equal to undefined because that's how we get vertical tangents. Vertical tangents happen when the derivative is undefined. So we would get that the denominator has to equal 0 for a fraction to be undefined, and you get that x is equal to negative 2y. Same exact thing happens. We actually end up having two variables left over when we're trying to solve that equation. So again, I'm going to take the original. I'm going to use the original, and I'm going to substitute in my x squared plus x times y plus y squared equals 27. We end up with 4y squared minus 2y squared plus y squared equals 27. We end up with 5, so 3y squared equals 27. So y is equal to plus or minus 3. So if you remember, we had that x is equal to negative 2y. So if y is equal to negative 3, then x is equal to 6. If y is equal to positive 3, then x is equal to negative 6. And I wrote these backwards, so just be careful as I'm checking my points. My original is right here, and that's what I'm going to use to check my point. X squared would be 36, plus xy, which would be negative 18, plus y squared, which would be 9, equals 27, true. And then the second one, x squared, 36, xy minus 18, and then y squared is plus 9 equals 27, true again. Therefore, both points work, so the answer to this question would be the point 6 comma negative 3 and negative 6 comma positive 3. All right, number 12, last one. Letter A, average rate of change from negative 1 to 2 would be f of 2 minus f of negative 1 all over 2 minus negative 1. So f of 2, f of 2 would be 33. F of negative 1 would be 0 and all over 3, so we get 11. Please just make sure that when you're doing f of negative 1, 4 times negative 1 cubed minus negative 1 squared plus 5. So you end up with 4 times negative 1, and then minus negative 1 squared is positive 1 plus 5. A lot of you get that wrong. So you get negative 4 minus 1 plus 5, which is how I got 0 as the value. Letter B asks for the instantaneous rate of change. Instantaneous rate of change is the derivative, so that's the difference. Average rate of change is the slope. Instantaneous rate of change is the derivative. So at 1, we would get 12 minus 2, which equals 10. There we go, numbers 8 through 12.